Good morning, students. Today we will learn the topic trigonometric identities. Actually, we have done till 8.2 exercise, but according to your new syllabus, 8.3 is not here. It's out of now syllabus, the complementary angle. So we will drop this portion and we'll skip directly at this particular exercise and we'll move on 8.4 exercise. So concept is trigonometric identities. A very important thing it is. Trigonometric identities. We have three major trigonometric identities. So one by one we will see all. Let me first make the, as usual, right angle triangle. Suppose it is A. Suppose it is A, it is B, it is C. And it is a right acute angle theta. This is right angle definitely. Front of theta, it is a perpendicular, it is a base, it is hypotenuse. And we know everything. Actually, we know sine theta is equal to perpendicular upon hypotenuse. Perpendicular upon hypotenuse. We know cos theta is equal to base upon hypotenuse. Tan theta is equal to perpendicular upon base. And three more, you know that cot theta is a reciprocal of tan theta. Sec theta is a reciprocal of cos theta, and cosec theta is a reciprocal of sin theta. So I am not specially mentioning them. Furthermore, what I am going to teach you, that is very important. This is right angle triangle. We know all the trigonometric ratios. The value I've written, 3 I mentioned here, 3 I am not. Okay. Now this is right angle triangle. For this acute angle, we have a perpendicular base and hypotenuse, each and everything, you know it. First, I am doing using Pythagoras theorem on that. What we will get? Hypotenuse square is equal to perpendicular square plus base square. So what is hypotenuse? It is AC. What is perpendicular? It is BC. And what is base? It is a BA. Now this is the important equation we got. For getting first identity, I will divide by this AC square in whole equation. For getting first identity, you will divide by AC square in whole the equation. So you have to keep remember only we have three things: AC square, BC square and BA square. So for getting different identities, we will divide by different one. First, for getting first identity, I will divide by AC square. Look at it. This is AC square, this is BC square, and this is BA square. These all three. I will divide by AC square. Look at it. Divide by AC square, divide by AC square, and divide by AC square. I have divided by AC square all. Look at these two cancelling by each other, it is 1. What about here? It's a BC upon AC whole square. Let me write BC upon AC whole square. And let me write BA upon AC whole square. BA upon AC whole square. Now don't go far, but BC upon AC, judge what is and where it is. BC upon AC is itself sine theta. So instead of BC upon AC, you write the sine theta whole square. And BA upon AC is none else, it is a cos theta. So write here cos theta. And now finally try to write in a well manner that it is sine theta square. It means sine square theta. Very first time square coming with trigonometric ratios. Try to understand. Sine theta whole square also can be written sine square theta. But that only in a bracket sign. Don't confuse about the thing. If you are writing like that, it is a wrong. They are not equal. They are not equal. Because it is angle square and it is whole square. So it is finally means sine square theta. These two are equal. But if you think that these two are equal, no, they are not equal. Okay, so keep remember that finally. And ultimately what we got, sine square theta plus this is cos square theta is equal to 1. So you got very first identity. If it is supposed to come in exam, prove that sine square theta plus cos square theta equal to 1. You have to go through all like that. And then you have got answer. Furthermore, I want to tell you something about we got a sine square theta plus cos square theta. This identity we have proved now. This is very first identity, meaning it is a formula. Now we also can create two more formula from this. First, I want to transfer to cos square theta that side only. So sin square theta will be 1 minus cos square theta. That is very simple. That is very simple. This you got it. Now, if you have sin square theta equal to 1 minus cos square theta, similarly, if you find the value of cos square theta, you will get 1 minus sin square theta. That is very simple. One time you transfer cos square theta, you will get this one. Second time you transfer sin square theta, you will get this one. So just below you have two more identities which actually created from this. This is the origin actually, and these are two sub-identities. But ultimately these are all the formulas. You have to remember, instead of sin square theta, you can write 1 minus cos square theta. Instead of cos square theta, you can write 1 minus sin square theta. And if both comes in plus, you have a 1. So this major identity, this is a major one, and these two created from this one. So okay, I think you have got very nicely till here. So let me run more and want to introduce to you again, what about cot theta? BA upon BC is a reciprocal of tan theta. What is sec theta? It is reciprocal with AC upon BA. And what is cosec theta? You know it, it is AC upon BC. So just for convenience, I just have written all. Now let me rub from here, because now I am going to tell you the another identity. And you remember my words that you have three things: AC square, BC square and BA square. You have to divide one by one. For getting all three identities, for first identity I divide by AC square. For getting second identity I will choose BC square. So I will write that divide by BC square, and let's watch that what happened. That it is AC square upon BC square is equal to that BC square upon BC square plus it is BA square upon BC square. Let's watch what will happen. What will happen? This is AC upon BC whole square. These BC and BC definitely cancel from each other, and that is BA upon BC whole square. Now you can see that I have already mentioned all the trigonometric ratios with all sides. Now you can catch AC upon BC, search AC upon BC here, sorry, AC upon BC here, it is cosec theta. So instead of that only I would write cosec theta square is equal to 1 plus that BA upon BC is looking here, BA upon BC, which is a cot theta. So I would write cot theta whole square. Ultimately I want to write it in a good manner, that it is not cosec theta whole square, it is a cosec square theta 1 plus this is cot theta whole square, it means cot square theta. Now this is the main identity. You can read by your own that cosec square theta will be written 1 plus cot square theta. Keep in mind always that all the identities are depending on square. With square they are all made. Cos square theta 1 plus cot square theta. Sometimes students get confused if I ask him or her that what is cosec theta. He or she says 1 plus cot theta. Sorry, but identity is just for with the square. Cosec square theta is equal to 1 plus cot square theta. Now this is a major one. Now you can just by transferring can create two more identities. Like what? You first transfer 1 here. So what you will get? Cosec square theta minus 1 equal to cot square theta, right? Say cosec square theta minus 1 equal to cot square theta. Now read it again from your side. Just reverse. Read reverse. Cot square theta is equal to cosec square theta minus 1. This is first, this is second. Now you have to remember like that. That cosec square theta equal to 1 plus cot square theta and cot square theta is equal to cosec square theta minus 1. So I left this because these two are major one. Actually these two are same only. I just have written this part here and this part here. So this is first and this is second. And what about the third one? I know that you can do it. Look at here. This was the major one. Now I would transfer. This time I did transfer to 1. I got a second sub-identity. Now I would transfer cot square theta. Look at it. It is cosec square theta and minus cot square theta is equal to 1. And this is a very important identity again. Look at science. First one which I told, what I told, sin square theta plus cos square theta was 1. Now this is second, in which we got cosec square theta minus cot square theta equal to 1. And this and this, these are all actually connected with each other. You have to remember all. instead of someone is coming cosec square theta, instead of that, if you require to write 1 plus cot square theta, you have to write. Suppose you have a cot square theta, you wanna write that term in a cosec theta, you have to write cosec square theta minus 1 instead of cot square theta. And the final one is very important, which is actually being cosec square theta minus cot square theta equal to 1. So all are connected. Now you have come to know that how we got all. Actually, this is very important thing, which is actually came from Pythagoras theorem. And by dividing one by one all the three sides with the square, we got all the identities spectrally. First I divided by AC square, I got a first identity which was a sin square theta plus cos square theta equal to 1. Second I divided by BC square, I got this. And now finally what I am going to do, you know it. I will choose BA square to divide. What will get? AC square upon BA square equal to BC square upon BA square plus BA square upon BA square. What will get? It is AC upon BA whole square. This is BC upon BA whole square. And it's very good that both cancel from each other, which is a 1. Now what to write it again? AC upon BA, search out AC upon BA, which is sec theta. So it is sec theta whole square. And BC upon BA is a tan theta. So tan theta whole square and plus 1. So I want to write as in a special formula format. It is sec square theta is equal to, I want to write 1 first and then tan theta square, meaning tan square theta. So this is a first identity. It's a very similar which we saw on the previous board here. What was the previous one? That was cosec square theta. This is a cot square theta. Now read it. Cosec square theta is equal to 1 plus cot square theta. Very simple that is. Now do transfer to 1 here. What will you get? Sec square theta minus 1 equal to tan square theta. And finally I want to write in a well manner. I want to write tan square theta initially is equal to sec square theta minus 1. That's the second identity. You understand? Now compared with the last one. Instead of tan, say cot. Instead of sec, say cosec. Now read. Cot square theta is equal to cosec square theta minus 1, which was the previous identity, which I made you write here on the same board. Now third, now transfer to tan square theta. Now you will get sec square theta minus tan square theta is equal to 1. This is again the third. Now you can see the star position. These is all are connected with each other. You have to remember all at the time. Now students, these are all the 3 identities and we have formed 9 identities from it. You have understood, I think. Now let me rub all. And now, hope student, this is a very important concept which I explained here. And based on these identities, we will see the further questions. So we have a simple question I want to put so that you can understand. You will understand about what I'm going to teach you. Look at question says example number 12 that express cos A, tan A and sec A in the form of sin A. This is a question. As far as the identities is concerned, let me write all the identities. Sin square theta plus cos square theta equal to 1. Based on sin square theta equal to 1 minus cos square theta. Based on cos square theta equal to 1 minus sin square theta. This is one family. Now moreover it is a cosec square theta is equal to 1 plus cot square theta. Cot square theta is equal to cosec square theta minus 1. And cosec square theta minus cot square theta equal to 1. This is another family. Now sec square theta is equal to 1 plus tan square theta. That tan square theta is equal to sec square theta minus 1. And lastly sec square theta minus tan square theta equal to 1. This is one family. So remember like a family, this one. Now the question is like that. Look at in a quick manner. Express cos A, tan A and sec A in the form of sin A. So first question is express cos A in the form of sin A. Okay, let me do it. Express cos A in the form of sin A. Look at, we know cos A is equal to cos square A is equal to 1 minus sin square A. Search out that this is a formula. Look at, cos square A equal to 1 minus sin square A. The theta used here, I'm using A. We know, look at, cos square A equal to 1 minus sin square A. Cos square A equal to 1 minus sin square A. If I use only cos A, I take a square root. Normally plus minus is used, but this here only you have to follow the plus sign. For all acute angle it is working, that's why. Don't follow the minus sign. In the further classes it will come, you don't worry about it. But in class 10 section, you just have to follow because A is always acute in this class. So take a positive sign only. So 1 minus sin square. And try to understand, very important thing, that I have taken the square root. So 1 minus sin square A. This is the answer of the first question. You can read, express cos A in the form of sin. Sin has come. This is first answer. Now what is tan A? Look at it, very interesting. First done. Second, tan A. So we are asked that express tan A in the form of sin A. Okay, I tell you that tan A is equal to, very simple, tan A is equal to, may I write sin A upon cos A? May I write sin A upon cos A? It's very simple formula, sin A upon cos A equal to tan A. We already have seen this. Now, question is, you have to turn to tan in the form of sin. You have to turn to tan in the form of sin. So it has come, sin A has come, but it is not sin. So change it. I tell you. You don't go far, that cos A already was 1 minus sin square A. So instead of that cos A, write 1 minus sin square A, because you should know that 1 minus sin square A equal to 1 minus sin square equal to cos square A, and it is cos square A in under root sin. When will come out, it is a cos A. Or if you don't want to think about all that, cos A already we have seen. Cos A we already seen that cos A is equal to what? Under root 1 minus sin square A. So instead of cos A, I can write 1 minus sin square A. Oh, can you see the answer? Tan A is in the form of sin A. Tan A has come in the form of sin A. So these two questions have done. Now what are the third one? Now it is sec A. Very simple. Sec A. What do you think?